couple more pieces of notation we want to have. The symbol, this guy, means is an element of, or is a member of. Okay, we place it between some object and a set to make a statement about, yeah, this guy's in there. Similarly, being clever mathematicians, the symbol this guy means is not an element of. Or is not a member of. Okay, similar to the other one, we put it between some object or some potential element and a set to make a statement about, yeah, that's not an element. That does not belong in here. Let's look at a couple examples of this notation, and I want to know true or false. So I've got Q is an element of the set that contains A, B, C, D, and so on, all the way to Z. Now, do I think that that's true or false? Well, since when I write down a set, I'm not trying to trick anybody. When I see, hey, this set has A, B, C, D, I assume, especially since it ends in Z, that this is going to have all of the lowercase letters of the English alphabet, which means that it will indeed hit Q at some point, and I say this is a true statement. Q is an element of the set A, B, C, D, and so on through Z, or the set containing A, B, C, D, and so on through Z. All right, true or false? 4 is an element of the set containing 1, 2, 8, 5, 4. True. How do I know? It's right there, right? There's no question in my mind that 4 is an element of that set because I can see it. It's right there. That's a true statement. All right, true or false? W is an element of the set with the members 1, 2, 3, 4, and so on. Now, you may think, oh, I need to be careful here. What if W is somewhere in that set? But remember, when we're talking about sets, we're all trying to work together. If I write this description of a set, it's my understanding that you will say, hey, the next thing after 4 should be 5. The next thing after 5 should be 6. And 7, and so on. I don't want you to assume, well, maybe this has letters in it. Maybe it goes some crazy way. Because since we're all working together, if I write down this set, I mean to say, hey, I want all the whole numbers greater than 1 or greater than or equal to 1, so 1, 2, 3, 4, 5, and so on. So W should not be in there, and this statement is false. Okay. W is an element of the set containing 1, 2, 3, 4, and so on is false. W is not an element of that set. Okay, let's look at this one. X is a member of the set of all X, such that X is a day of the week. Now, I see X in there and I may think, oh, well, X must be a member of that set. But remember, all of these pieces on the outside are just window dressing around the description of this set. The only things that belong in this set are things that I can put into that description where X used to be and have be true. So in fact, this set, we already know, is Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday, those are the only 7 things in that set. I guess I should have made this red. I was going to make the other side red. Those are the only 7 things in that set. X is not one of those things, because if I say X is the day of the week, that's not true. So this statement, X is an element of the set of all X such that X is a day of the week, is false. X is not in that set, so that is a false statement. All right, here I have 8 is not a member of the set of all X such that X is an even number. Well, even numbers are guys like 2, 0, 4, -2, 8, 6, -4. Okay, I did not order those in a very nice way. But those are the types of things in this set. And this statement has a problem because, in fact, 8 is an even number. So this statement to be true would be 8 is an element of the set of all X such that X is an even number. Which means that my original statement is false. So I think I can write the word false here. There. So that statement is false because 8 is a member of that set. Okay, finally, 15 is not a member of the set of all X such that X is a prime number. So I have to look at this set and say to myself, well, what things are in there? Well, if you go back or look at your definition of prime numbers, so this is all the numbers greater than 1 whose only factors are 1 in itself. So that's 1, 3, 5, 7, 11, 13, 17, 19, and that's probably not quite enough to put ... But if I label it as prime numbers, it might help. Anyway, that set is numbers like this, numbers whose only factors are 1 in itself. 15 I can write as 3 times 5, so 15 is not prime, which means 15 is not in this set, which is what that sentence says. 15 is not a member of the set of all X such that X is a prime number. That's true. That is a true statement.